Hi, I'm Michelle Segrest, and welcome to the Factory of the Future podcast. This podcast is inspired by my 3-volume book series on the evolution of modern manufacturing. Each episode features engaging conversations with game-changing experts discussing the processes and innovations that are changing the landscape of modern manufacturing. Thank you so much for listening. Please do me a favor and leave me a 5-star rating on iTunes and take just a couple of seconds to leave a review. And then go ahead and hit that subscribe button right now so you don't miss a single episode. Today, I am so excited to welcome Sanya Mathura as my expert guest. Sanya is the founder of Strategic Reliability Solutions Limited, based in Trinidad, and she operates in the capacity of managing director and senior consultant. She works with global affiliates in the areas of reliability and asset management to bring these specialty niches to her clients. Sanya possesses a strong engineering background with a BSc in electrical and computer engineering and an MSc in engineering asset management. She has worked in the lubrication industry for the past several years and has used her engineering background to assist various industries with lubrication-related issues, both locally in Trinidad and Tobago, regionally, and internationally. She has solved lubrication problems and provided training in the automotive, industrial, marine, construction, and transportation sectors. Sanya is the first person, and that also makes her the first female in her country, Trinidad and Tobago, and by extension, the Caribbean, to attain an ICML MLE, which stands for International Council for Machinery Lubrication Engineer Certification. She has also published her first book, Lubrication Degradation Mechanisms, a complete guide, and we are going to talk about this a lot today. I'm so excited now to welcome Sanya to the podcast. Sanya, it's so great to have you here.
It is great to be here, Michelle. Thank you so much for having me and for being excited about the book as well.
Of course, it's my pleasure. It's a treat for all of us to learn a little bit more about the book and about your background. First of all, I listed some of your accomplishments, but I'm interested to know just a little bit more about your background. Can you tell us how you became interested in engineering and how that evolved to creating your own company?
Oh boy, yes, you had a lot to read in the beginning there. There's a lot of things you have to read out.
That's right. You're very accomplished.
Initially, when I started growing up, I loved fixing things. I loved making things more efficient, just making sure that it's a little bit better than it was before. It could be anything, even right now, getting a grocery list done. So if I'm putting my grocery list together, I'm writing down the different items via the lane because I know the grocery by like the back of my hand with the amount of times I'm in there. So I'm writing them down by the lane because I know this is where I need to go to get stuff.
So this translates to everything, right?
It does.
Meticulous nature.
Oh my gosh, it gets into everything. And what you realize is that you start looking for different ways of making things more efficient. Growing up, I always knew I wanted to go into engineering, but I didn't have any female engineers to look up to. And that was an issue for me. And it sounds a bit bad or a bit weird, but we didn't have the internet while we were growing up, right?
Right.
Google didn't exist.
I didn't either, of course.
Now I sound old. Google didn't exist yet.
Hey, listen, I'm from that generation too, so
yes,
I'm with you.
Girl, strong with it.
That's right.
So I wanted to make sure that I changed that for other girls or other women, let them have a role model within the engineering sector. Be that role model, because I didn't have that when I was growing up. So one of my main things that I'm very passionate about is getting more women involved in STEM, getting girls involved in STEM, because I think there's so much that we can offer and so much things that we can do, because we think a bit differently and we're not as mechanically minded in some parts, because I know my MSc is in mechanical engineering, so I am a bit mechanically minded too.
Right, right. It's so interesting. I don't mean to interrupt you, but almost every engineer I talk to, whether it's a man or a woman, talk about how growing up they love to fix things. They love to
Yes.
take things apart and put things back together. That seems to be a common thread among
Hmm.
most people who fall in love with engineering.
We may need to investigate that. Definitely.
I guess it's just in your nature. It seems like
Yeah.
if you like to fix things and you like to learn how things work, maybe
Hmm.
engineering is the career for you. And maybe this is something that
Definitely.
little girls around the world don't really realize
No,
that
maybe
it's out
not.
there.
And that's what we need to change. That's what we need to get them more involved and let them know that there are other women out there. You have company, you have mentors, you have people that you can go to. And I think that's one of the things that we struggle with a lot within the industry in particular, because
Hmm.
we don't know who to go to. We're not sure, who do we look up to? Who do we go to for advice? So mentors are critical, very, very
I can see
critical.
that. But just real quick, if you didn't have the internet and Google didn't
Mhm.
exist when you were growing up and you were how did you even know that engineering was a thing? How did you
I
come to
had
learn that that's what you should do?
I had some family members within engineering, and I was like, I think that's what I want to do. But
Okay.
I
So you had
never,
some role models. They just weren't
they
female
just
role
weren't
models.
female. Yeah.
Okay. So they kind of introduced you to and maybe recognized in you that you had this
Yes,
capacity to fix things and to solve
definitely.
problems. And maybe they encouraged you to do engineering. Is that true?
Yeah. In some small ways, yes. But when you start thinking about the world of engineering, you start thinking about math, you start thinking about the equations, and you're like, do I really want to go into that part? But
Right.
from what I've understood now, the math and whatnot, it's not as relevant now because we have so much automation within the world that what you really need to know is how to apply yourself and how to get these things done. There's an app for that.
Right. There's an app for
There's an
that.
app for that.
Exactly. Exactly. So it's not just math. It's so
No,
you don't have to be great in math to
I
be
don't
an
think
engineer.
so. I don't think so. I think you just need to have that passion, that skill, and be willing to learn and adapt. And you can do anything that you want to do, engineering included.
That makes perfect sense. You're certainly a good representation of that theory. So
Oh, thank
that's
you.
good. So tell us how you got into lubrication specifically.
So it's actually a bit weird because my bachelor's it's in electrical and computer engineering. That has nothing to do with lubrication. But after I did my bachelor's and I worked within the field for a bit, I ended up getting a job within the lubrication sector as a technical person, and I was introduced to it because I was working with Shell lubricants, and I started to be introduced the way that machines use lubrication. And that got me interested not only in lubrication, but in reliability and the way that reliability works with every single different aspect. And I love that about it.
Hmm.
And that's when I decided to pursue my master's in engineering asset management. And while doing my master's, of course, I did my thesis on something lubrication related. Why not?
Yes.
Because I love that aspect of it. While I was doing my thesis, I realized that I wasn't putting forward the best quality that I could have. And quality is very, very important to me. So what I did is that I quit my job to sit down at home and write my thesis. Would you
Ah,
believe that?
well, it takes a lot of courage to do
Yes,
something like
yes,
that.
it does. But at that point in my life, I was like, this thesis, I need it to be the best that it can be. And I am going to sit down and I'm going to work on it and I'm going to get it done. And while doing my thesis, I believe my eyes were opened in that I started to reach out to different professionals, different SMEs all over the globe. And to
Hmm.
my very much to my surprise, they actually responded to me when I asked them questions. And they were so helpful and they were able to give me the information that I needed to complete my thesis. And without that, I would not have been able to do my thesis in the first place, because just doing a random Google search online is not going to get you the information that you need.
That's right.
And that's what sort of brainstormed the entire idea behind strategic reliability solution. Because I realized at that point that I wanted to be able to be the conduit where people could go to for information, specialized information related to reliability, some sort of solution. And guess what? It had to be strategic. So that's how we came up with the name.
That's the perfect name. It tells you exactly.
Right?
Yeah, it tells you exactly what the company is, Strategic Reliability Solutions.
Exactly.
And what do? You provide strategic reliability solutions. So that makes perfect sense. Yes. I think it's really interesting because you talked about not having Google or internet growing up. And then when you started working on your thesis, that wasn't where you went. You went to the people, and the people were happy to share their knowledge. This really is a knowledge sharing community. I have found this out through my reporting as well. If you just call, people are willing to talk to you and share their knowledge. I love that about this industry.
And I think with the reliability and maintenance industry, it's different from other industries, because I've worked with some of the other industries before, and they aren't as open to sharing information. And I'm like, why aren't you so open? It's all about collaboration. We could do so much together and be able to solve so many more problems if we work together rather than staying apart and thinking, okay, I'm going to hoard all of my information. No, let's share. Let's, help each other along the way. That's what we're here for.
Well, that's how you solve the most problems, is by collaboration and getting other ideas. And I know that you're based in Trinidad and Tobago, but you have affiliates all across the globe, right?
Oh boy, yes, I do. It's very interesting because I have a bunch of affiliates in the US, and each affiliate, they represent a different part of the reliability industry. So it all goes back into building up the entire reliability core. So we have our guys in Virginia. They are Reliability Center Incorporated, Bob Latino. They handle root cause analysis. He is so good.
Oh, yes, I know him. He's fantastic.
And his father founded reliability within the industry. Who better to partner with?
That's right. That's a great partner.
We also have East Partnership, and they do LORA, which is level of repair analysis, and maintenance task analysis. And I love working with Lucas because Lucas provides a platform for different entrepreneurs so they can actually host their on-demand courses. So we actually have some lubrication on-demand courses hosted at East Partnership with Lucas. So it's been amazing working with him. We have affiliates in Texas as well. They are called Fifth Order Industry, Michael Holloway. And he is the go-to guy for anything ICML or even STLE certification related. So he handles all the lubrication certification with that. He's our dedicated trainer for that. He's amazing. This guy knows his stuff. We also have the guys in PM ProLearn, and they are all ex-Army, ex-military. They provide services for PMP certification. And it's been amazing working with them because they're so efficient and they have everything mapped out. And I love working with them because they also work with lots of veterans in the US and globally. So it's been great working with them. And then we have Conscious Reliability in Canada. That's Jesus Sifonte. He does RCMR, which is Reliability Centered Maintenance Re-Engineered. And what he found was that while RCM was applied to the aviation industry, he wanted to make it more applicable to the actual industry, like healthcare or manufacturing. So that's why he developed RCMR. When he teaches a course, he blows everybody away. And he's also bilingual, so that helps our Spanish community as well.
Wonderful.
And we have our last affiliate in Australia, Eric. And what he does is that he handles maintenance planning and scheduling. Like, Eric is my go-to guy for maintenance planning and scheduling. He knows everything there is to know about it. And he's developed these on-demand courses that really get students to think more and to be able to apply those practices. It's not just okay, this is what you learn. No, he helps you to apply it and make sure that you actually understand the principles involved so that you can apply it to your industry or department, anything. He's our go-to guy. So we're global in terms of affiliates, and it's been amazing working with all of them, especially when COVID hits. We usually do in-person trainings. It was great having them all on board to try and figure out how are we going to navigate this industry, this change in industry now, and navigate it as a team. And that's what I loved about it.
Yes, that's wonderful. It's a very diverse group, and everyone has their particular specialties, but they all come back to reliability. That's what I see from what you just described. It's all about reliability. So I'm just curious, what is your definition of reliability?
My definition of reliability is just making sure that it works better than it was before.
Oh, that's a perfect definition.
We're just taking it very simple, because what I've realized within the industry, we tend to make these complex, definitions, and then nobody understands it. Right. And it just goes over everybody's head. You know what? We just want to make it better than it was before, so you have a better efficiency and you can work easier, better, safer. That's it.
And that's interesting too, because you never stop striving for this, because every single day you can make it a little bit better than it was before. So you never quite get there, right?
Nope.
That you can always be more reliable. And so that's, I'm sure, always the goal.
Yeah, we are all works in progress.
Yes, that's really cool, because you always have something to be striving for. Let's talk a little bit specifically about your book. I'm really interested to learn a little bit more about the book. At the end of the podcast, we'll give you a discount code to get this book. So stick around to the end for that. Sanya, can you tell us what the book is about, and tell us, who did you write it for? Who is the audience, and why did you decide to write it?
So this goes back to my thesis again.
Okay.
When I was doing my thesis, I was trying to get all of this information about the degradation of a lubricant, and it wasn't really available. And I figured, if I am struggling to get this information, there must be other people struggling as well. I know I'm not the only one.
Well, for those of us who don't know, those of us who are not reliability engineers, what is lubrication degradation?
Simply, whenever you put a lubricant into a piece of equipment, into your car, the first thing that will happen to it is that it will start to reduce friction. It will start to perform its different functions. And one of the things about lubricants is that they are sacrificial in nature. So when they're performing their functions, they will lose parts of themselves. So they would have additives to increase performance. Those would start to be depleted as the lubricant is being used. So from the moment it enters the equipment, it will start to degrade. And when that becomes a problem is when it starts to affect its function. So when it can no longer perform the function it's supposed to, then we have an issue. The lubricant has degraded to a point where it's no longer serviceable. So that's what we talk about when we talk about lubrication degradation.
Okay, that makes perfect sense. So I didn't mean to interrupt you, but I wanted to clarify that. And then, so continue telling us about how the book came about in the audience and the story behind the book.
When I was doing my thesis, I got the information, and I always thought to myself, I would love to be able to put this information out there so that other people could benefit from it. They could learn, they could understand. And after forming the company, things were a bit hectic and whatnot. Then COVID happened, and I'm like, okay, you know what? Nobody's going to be calling me for a while. I'm going to enjoy this downtime and just sit down and write this book and get it out there. And that's what I did.
Good for you.
It helped that nobody was calling, and I know there were a bunch of meetings and whatnot. So that definitely
you took something
helped.
bad and turned it into something good. You made productive use of that time, which is fantastic.
Oh gosh, yes, definitely. And when I started to write the book, I wanted to make sure that anybody picking up the book could actually understand it. So it's written from the point of talking about the basics of lubrication at first, so that people understand. And I think I use so many different analogies in the beginning of the book just so that people get the basics right.
Right.
And then we start going into the more complex stuff. So anybody who has ever had to deal with lubricants, in their machines, picking up this book, they can start off with it and they can get into understanding different degradation mechanisms. Because we
Fantastic.
talk about basics of lubrication, then we talk about how do you identify the different degradation mechanisms? What is different about one to the other? And then we go into the different types of tests that they could do. Because guess what? Everybody wants to confirm something in the lab, and we need the lab to help us. And then we talk about dealing with the degradation mechanisms. What can you do once you've realized that this is what is going on in your system? And there are 6 degradation mechanisms. Let me just tell you one time.
Yeah, that'd be awesome. Please.
So there are 6. There's not just one, because everybody thinks if the lubricant degrades, it's oxidation. It's not. Oxidation is the most common one, but there are 6 different degradation mechanisms. You have oxidation, you have thermal degradation, you have microdieseling, electrostatic spark discharge, additive depletion, and of course, contamination. And a lot of people talk about contamination. They're like, contamination cannot be a degradation mechanism. But if you think about it, it has to be a degradation mechanism, because if you don't treat the system for contamination, then you may not be treating what is causing the system to get all of the degradation to happen. And to help you to understand that, it's as though you go to the doctor and you have a headache and he gives you some medicine for a heart attack. So he's treating the wrong thing. So that's what we talk about, making sure that contamination is one of the degradation mechanisms involved there. Because if you have contamination happening, then you have different things coming into your system. And what could happen there is that after you have those come in, it could actually spark another degradation mechanism. So it could spark oxidation, or it could spark microdieseling. If you just identify oxidation or microdieseling and you solve for that, then you're not going to solve the problem, because you're still having the contaminants coming in.
Are there ways to determine how many of these different, because you said that there can be a combination of these 6 different types of degradation. So how do you determine what it is and which of those components are affecting your system?
Oh, that's a great question. So each of the different components, of course, I like talking about this. Each of the different mechanisms, they produce different results. So in oxidation, you would see sludge, you would see varnish. But in thermal degradation, you would see carbon deposits. And there are different things that happen to your oil. In oxidation, your viscosity of your oil increases, whereas in thermal degradation, the viscosity decreases. And we actually have this in the book. We have a flow chart of being able to identify the different mechanism from what you see with your oil analysis or what you see with your components. So it all goes back to trying to identify which of the mechanisms you have at play, and then deciding, okay, how do we deal with this?
That makes sense.
Yeah.
So once you learn all that, then you're able to identify the cause and effect, or what happens on the other side. And then you can create a solution to fix it.
Oh, yeah, definitely.
Once you have that data. That's really interesting. So tell us about some of the problems that are happening in manufacturing today that this book can help to solve. And it'd be great if you could give us some specific examples.
I will definitely do that. So we talked about this before. Once something moves, it needs some sort of lubrication. If you think about, if you rub your hands together and you rub them really fast, your hands are going to start getting hot. But if you put cream between your hands, it's not going to get hot. You've just lubricated your hands.
Right,
so everything that moves needs lubrication. Okay. And when you think about manufacturing, you think about a lot of different moving parts. Oh my gosh.
For sure.
You have rollers, you have bearings, you have conveyors, you have gearboxes. Oh my gosh, you have a lot of these things. Right. And everything needs lubrication. But when you start looking at the way in which a gear oil may degrade, it would be different from that of a grease. A grease would degrade differently from a gear oil. And if we're thinking about gearboxes, One of the things with gearboxes is that they usually experience a degradation mechanism called microdieseling. No, this has nothing to do with diesel,
Uh-huh.
but in microdieseling, what happens is that you actually have air that is entrained into your oil. And when that moves from a low pressure to a high pressure, it combusts.
Mm-hmm.
And when that happens, it can damage your equipment. So you can have some sort of cavitation going on the inside. You'd see a little bit of pitting on the inside of your equipment when you open it up, because those are the bubbles exploding and damaging your equipment. Nobody wants that. When the bubbles explode, they actually produce different things like carbon or soot or tar, sludge, and being able to identify that you have that mechanism ongoing, what you need to do then is sort of take a look back and say, okay, well, how can this happen? Do I have air coming in from anywhere else within my gearbox? Do I have a leak? Is it that my gears are churning too much? So they are churning the oil and introducing air into the equipment. What can I do to prevent this? And with microdieseling, one of the things that you can do is install a baffle plate.
Mm-hmm.
And these baffle plates, it's a plate that has holes in it.
Ah,
Basic
yes.
explanation.
Okay.
So what those holes do is that they trap the air in it, so that the air is no longer entrained in the oil and is a bit removed. So you don't have the cavitation or the whole microdieseling effect happening. So that's one of the easiest ways to solve
Yes,
microdieseling.
good. That's a great
Yeah.
example. I can get a really good picture of that. That was
Nice.
great. You said the book was all about knowledge sharing. Like you wanted to make sure people had a resource to get this kind of knowledge and this kind of information. And then it's all about solving problems. So what kind of feedback have you received from the book so far? Do you think it's
Oh
doing what you
my.
wanted it to do?
Yes, I think so. I was like blown away when I got the first, feedback.
Uh-huh.
The thing about this book is that I wrote it. I was in Trinidad. I did not move because we closed our borders because of COVID. Everything was done online. I sent the information back and forth with CRC Press, and they published the book. And I wasn't the first person to get the book. I had a colleague in the UK, and he's like, "Oh my gosh, Sunny, I just got your book," and I'm like, "I didn't see it yet."
Oh, your friend got it. Your colleague got it before you
Yes,
did.
he got it before I did, and he lives all the way in the UK.
That's pretty funny.
Yeah, because we had some shipping challenges and whatnot just to get it to Trinidad in time. So he got it a week before I did. I was just happy that he did get it, and
Well, sure.
yeah, I'm glad somebody did. And we've actually been having it hasn't been 6 months since it's launched, which is crazy in my mind, but we have more than 65 copies sold globally, which is
Wonderful.
amazing. I'm thinking when I wrote it,
Congratulations.
I didn't think that, we would have that kind of response or that amount of people being so excited about it. And I've had people in Brazil, India, in Australia, basically all over telling me about, oh my gosh, now I understand what those mechanisms mean. Now I understand what happens in the equipment. And you've just removed all of those smoke and mirrors that we had surrounding lubrication in the past. And I actually understand now what lubrication is, how to apply it, how to understand the different mechanisms. This book is definitely traveling more than I am.
Of course, this book is traveling more than any
Oh
of
my,
us
yeah,
are, I
yeah,
think.
yeah. It doesn't even need a vaccine. It's going. It's just, all the way
That's
around.
right. That's right. Well, I'm so happy for you. I'm so happy that it's being so well received and that it's reaching the audience that you really hoped it would reach. So congratulations on that. I
Thank
know
you
you're
for
very, very
that.
proud. I know how that
Oh yeah.
feels with some of the books that I've published. You
Yes.
get feedback from someone and you're like, how did they know? How did they even know about
Yes.
this book? How did they
Oh
find
my
out? And
gosh.
it really does make you feel good to know that your goal of educating someone or helping them solve a problem was accomplished. So
Yes,
you should be very proud.
definitely. Yay!
Well, Sonia, as you know, this podcast is all about the future of manufacturing. And I'm
Mm-hmm.
so interested in learning not just what the future holds, but I like to go back and look at the history of
Mm.
manufacturing and kind of the past, the present, and the future. And so I'm wondering if you could tell us a little bit about the evolution of this particular topic of lubrication degradation systems within manufacturing. So what is the past, present, and most important, the future look like with regard to this topic?
Well, it's very interesting that you mentioned that because I think even though lubrication degradation existed for all time, we were not paying as much attention to it in the past.
Mm-hmm.
Because in the past, we had a lot more robust systems. We didn't have as much technology involved. And one thing that I like to bring up, because a lot of users remember that, especially in the lubrication industry, is that there was this major change of the base oils from Group 1 base oils to Group 2 base oils. And it affected a lot of the turbine users in particular. And the reason this resonates so much with me is that at the time that I was entering the industry, that's when the change occurred. So I was at the forefront in terms of the users telling me we didn't have varnish before. Now that they've changed this base oil, we're getting varnish. How did that happen? Did somebody did not do their research or something like that? But when we had that change from Group 1 to Group 2 base oils are supposed to have a better solvency. But what happens is that when you have varnish being produced in your oil, with your Group 1 base oils, they remained in solution in the oil. So they didn't plate out and varnish and muck up all of the equipment. But when they moved to Group 2 base oils, those base oils could not hold those things in solution anymore. So it's almost like when you're doing a sugar solution. So if you have a glass of water and you add in sugar to it, if you keep adding sugar to it, there will be a point where not all of the sugar is going to be dissolved. Some of it is going to remain at the bottom of the glass. Same thing with the varnish. The oils could not hold the amount of varnish that was being produced compared to the Group 1 base oils. I think that helped to spark the change for condition monitoring. So now people wanted to monitor their equipment. They wanted to be more aware of what was going on with their oil to be able to track these changes. Because when varnish occurs, guess what? The system goes down and you lose a lot of money. You have unplanned shutdowns, you have downtime, really expensive parts coming
Well,
in.
as we know, that's the worst thing that can happen in
Oh gosh,
manufacturing.
yes. Oh my gosh, definitely.
Without a doubt, right?
Yes. So nobody wants that. So that's why they started introducing a lot more condition monitoring. Condition monitoring is fine, you do your oil analysis, but what tests do you do? How often do you test? What do the results mean when they come back? Just knowing that you want to do oil analysis is not enough anymore. Being able to design a program that is aligned with your equipment, because if we have critical pieces of equipment, we would want to be monitoring those at all times. Whereas if we have like a secondary pump, we're not going to monitor that as often or give that as much preference compared to our critical equipment. So while we had that shift within the industry to move towards better condition monitoring, what we had to do as well was put things in place to understand the results. And that's where a lot of people, they falter. They're like, okay, yes, we have this beautiful program in place, but nobody understands when the results come back from the lab.
Right.
They don't know. So in the past, we would not have been monitoring as much with condition monitoring with oils. Now we're at the stage where we're monitoring a lot more and we're now starting to understand it. And in the future, what I anticipate is that we're going to get to the point, and I know AI is going to have some sort of contribution in here to help match conditions, results to what the different types of degradations, and not just match it, but give us some sort of feedback in terms of this is what we should be doing right now. This is what we're seeing going on in the equipment. These are the things we need to put into place. This is how much time we have before we have that critical failure. And I think that is the most important thing with any manufacturing, anything. We want to know how long it is before it fails.
Sure.
Because
Yeah.
obviously we want to run product through that like crazy before it goes out.
Of course. Of course.
So what I
That's
see is IoT playing a higher role, and I think COVID helped a lot with that because we weren't allowed different facilities, they weren't allowed to have their full staff out. So how do you control your equipment from different parts of the world?
It's interesting because I've actually interviewed a lot of people since the outbreak of COVID who have said the exact same thing, that it's forced us to use
Yes.
technology. And whether we wanted to or not, we had to during this time. In particular, with regard to condition monitoring and remote monitoring. If companies were waiting to try it, I mean, in this case, they were forced to. They couldn't wait anymore. It was the only way to do business. And so I'm hearing that a lot. It's interesting that you said that. I think worldwide that's awakened people to this need to be remote and
connected
and to be automated. Well, that's definitely a manufacturing trend that I'm seeing that you just mentioned. Are there any others that you can tell us about that you're seeing with your clients?
What I'm seeing is that a lot of them are moving towards sensors. In the past, they would have taken an oil sample, sent it off to the lab, wait a few days accordingly to the lab return time. But what they're trying to do now is that they're trying to do a lot more sensors into the equipment. And with that, like anything, once we have more data, we could trend better. So ongoing data points, that helps in terms of trending. And what they're trying to do as well is reduce the amount of man hours involved in terms of taking a sample. How can they automate that? I'm seeing some of the labs as well getting very innovative in terms of automating the handling of samples as they come in. So they don't necessarily need to have a human station there to physically go through all of the samples, sorting them and whatnot. So there, in the past, especially with oil samples, you would have had somebody write on a label, this came from this pump at whatever hours and whatever dates. But now sometimes you just say a barcode, a QR code, and the user on the other side would have entered the information on the system and everything is linked. So somebody is just scanning that QR code and they know exactly what that oil sample is for. So I anticipate we're going to have a lot more of that in the future. And once it makes the process more efficient, I'm all for that.
Absolutely, of course. Sanya, I really want to talk a little bit about women in industry. This is a topic that's very important to you. It's very important to me. And more specifically, I want to talk about women in STEM, in the STEM fields. Can you talk about the role women are playing in industry and the impact this is having?
I think a lot more women are getting involved in the industry now. And I think it's because we're having this major change. We have a lot more women being open to getting out into those STEM fields, getting out into those previously male-dominated fields, and just being the best that they can be. And that is amazing. And compared to what we've had in the past, we haven't had as much women in engineering or in other fields of STEM, but now we're really seeing a lot more women coming into it. And what I am very passionate about is having those role models for the future generation looking on. And since I published my book with CRC Press, they actually approached me recently and they were interested in doing a book series where we talk about women in STEM. And I am trying to lead that change in that we're going to have a lot more women involved in STEM being authors so that we capture their journey. We capture what it was like for them to go through this entire process and to sort of put it in the form of a guide for other women in the industry who may be experiencing similar things. But like we started off this podcast talking about, they didn't know who to talk to. They didn't know where to turn to, resources. but we want to make sure that a lot more women have people they could reach out to, have people that they could relate to. Some of their stories may resonate with them and help them to, make some changes or even go after what they wanted to do all this time, but they felt, they were being pulled back. Just give them that support, that encouragement, give them that courage to go forward. So what we're doing is we're actually putting together this series and we're just starting to do it. So if anybody is interested, reach out to me. Always willing to collaborate. So let me know if you're interested in it, because we're putting together this series for different authors. We want to, and this is not just limited to women. We have a lot of men, and I will say it's without those guys helping us, we would not be able to get as far as we are today. So it's not just a black and white version of things. There is a lot of gray involved. And we are going to be having some male authors helping us along this journey. They're going to help document what they've seen from their side, from their perspective. So we definitely want to make it balanced, because without our male colleagues, we would not be where we are today. And I'm very grateful for all of the guys that help me continuously within my field, because they are wonderful.
Even though it's a male-dominated field right now, it may not be always, but right now it is a male-dominated field. But I have not run into a single male engineer who was not encouraging to women to get involved. I think they see the value. It's not about if you're a man or a woman, it's about what you know and what you want to share and how you solve problems and how you help others with the information and the knowledge that you possess. And so I think it's wonderful. I know that you said you wanted, when you talked to me about this, and I am going to be involved in this. I'm so excited to be involved in this project. But you said we want to ensure that any little girl or little boy can have mentors within STEM. They can have people that they can look up to and say, hey, I want to be like that person and help change the world. And I just love this. And it's so inspiring. I'm so excited that you're doing it. I'm so excited to be a part of it. I have interviewed hundreds of men and women in STEM, and they all have such an interesting story to tell. So I'm happy to tell some of those stories as a messenger. Of course, I'm not in STEM directly, but I sure do write about it a lot.
Yes,
and
definitely.
I'm so happy to share some of those stories. So we will definitely be talking a little bit more about this program and probably have you back on, Sanya, when it launches to
let me know.
tell people about it. And we'll continue to provide some more information along the way. In the meantime, I'll put something in the show notes, a link to your website, or you give me, I'll put your email or something. And then people who are interested can just click that link and find out more information. So I'm really excited about that. I want you all to be looking for that in the future. We'll be covering that a lot more.
We are in the process. We are getting that started.
I know. It's so exciting. It's such an exciting project. And I'm so happy to be a part of it. So Sanya, as we talk about the future of manufacturing, I'm just wondering, you have a lot of clients out there worldwide. Do you think that most companies are effectively preparing for the future? And if not, why not? How do you feel about that?
I think, honestly, that COVID has helped us to be able to prepare better. It was not scheduled. This is just
exactly.
It's just like an unscheduled shutdown. It helped a lot of us to refocus, to adapt, to change, and to be willing to adapt to that change. Because I think in the past, we were so focused on, okay, this is what we do this well, and we are going to remain in this pattern. But we never thought about how can we do this differently. And I think COVID has sparked that for a lot of us, helping us to think a bit more outside of the box, think about the future. Okay, well, is this really sustainable? Can we go forward with this? What are the implications? And I think definitely it has prepared us to get all of our companies to prepare for the future. And for those of them that didn't, when they not being able to adapt to that change did not help them in terms of moving forward. So I think even that is a major learning point. If you're not willing to adapt or pivot, the word for 2020.
Yeah, that's right. I mean,
You're
I
not
completely
even,
agree
yeah.
with you. I completely agree with you. I see this, and it kind of goes back to your definition of reliability, and that's getting a little bit better every day. And in order to do that, you have to embrace new technology. You have to embrace change. You have to embrace innovation. And I know it's hard. We talk a lot on this program about the machine whisperers, the guys that just go
Yes.
out into the plant floor and they can feel and hear and see where their machine is not operating properly. But those guys have to learn how to use technology too. And the new guys coming in are so tech savvy. The young kids who are just entering the field, they've grown up with computers. They grew up with Google and the
They
internet where
did.
you and I didn't. And so they're very tech savvy, but these old, I like to call them machine whisperers, they have to embrace the automation as well and learn new skills because they're going to be gone soon and they'll retire and
Yes.
take their knowledge with them and take those sensory ways of telling what's wrong with the computer. They take those with them. You can't teach that kind of thing, but you can teach people how to use technology, right?
Yes, definitely.
Yeah. Sanya, this has been such a great conversation. I could talk to you all day. I really want to thank you for being here with us and sharing your knowledge and expertise and also information about the book. We'll give some more information about that in just a few minutes. But before we conclude, I just want to give you the last word. Is there anything else you want to tell us about your book or about women in industry or about the future of manufacturing or about lubrication degradation systems?
My last word is just for everyone to honestly be your best self and be uniquely you. I'm not going to talk about the book. We talked about that already. What I want you to do, just anybody listening to the podcast, is just be open, always be curious about finding out about why things work the way that they do. Or if you have any questions, just always ask questions. Don't hold back on that. And just be able to think a little bit about, okay, this is how I want to add value to the industry. This is how I'm going to do it. So be your best self, be uniquely you, and continue to be uniquely you. That's all that you can be.
Well, that is just the best advice I've heard in a long, long time. I love that.
Okay.
That is wonderful. And that's a great way to end it. But before we do, I do want to give our listeners just a little bit more information about your book. So the name of the book is Lubrication Degradation Mechanisms, a Complete Guide. The author, of course, is Sanya Mathura, who we've been talking to today. In industry, owners, engineers, and workers have struggled with lubricant degradation and its effects on their equipment. The purpose of this book, Lubrication Degradation Mechanisms, a Complete Guide, is to help personnel to understand the reasons behind the degradation of their lubricant, to determine methods to identify the onset of degradation and reduce or eliminate lubricant degradation within their equipment. One of the most common forms of lubricant degradation is oxidation. However, this is not the only method by which a lubricant degrades. By understanding the differences between degradation patterns, personnel can employ specific tasks and tests to aid in their identification of the type of degradation and the factors responsible. The aim of this book is to educate facility personnel on the methods of degradation and ways in which it can be reduced or eliminated while keeping an eye on the cost of operation. This book is available at www.routledge.com, and I'll put a link to that in the show notes. So all you have to do, you don't have to spell it. All you have to do is click the link, and the listeners of this podcast can receive a 20% discount on the book. All you have to do is enter the code ADC21 at checkout, and I'll include that with the link so you can remember that discount code. This brings us to the end of the show. Thank you so much for listening. Please do me a favor and subscribe, rate, and review the podcast on iTunes. If you have interesting information to share and want to contact me about being a guest on a future episode of this podcast, please send me an email at michelle@navigatecontent.com. You can also send me questions that I will have my expert guests answer for you on a future episode. And in the meantime, please check out my book series on modern manufacturing to read more than 30 real-world case studies about how global companies are using smart technology and innovation to build the factory of the future. All the links to the books and articles mentioned in this podcast are in the show notes. Have a great week, and please join me for the next episode of Factory of the Future.